All right, hopefully. So, like I have f of x. Any ideas?
Try re-clicking the pencil. Maybe.
Just snap it.
Let's not do that.
Yeah, that'd be an expensive paycheck for the university. Merry Christmas.
Does that have something to do with the presenting? No, or is that the,
That's the
That way to the university has instead of inviting for 6 hours. I can't do it.
technology in this classroom worked for too long. Come on, open up, please.
This one just saved.
I said, this
So the reality is, this is how my day's been going.
Well, I think you need to go home, call it.
You do? Are you gonna come up and teach?
I will.
Okay.
I will use an anticipation part.
Yay!
the percentage.
I think if I do it, it's the whole grade. The whole grade.
All right, so let's say that I have f of x is equal to 2x minus 5, and g of x is equal to x plus 8. Okay, when we're going to do a composite function, it's going to be written as f of g of x, or it might be g of f of x. But you got just this little o for of there. Whatever is on the inside, I'm going to insert g into f. Or if it's written like this, I'm going to insert f into g. Okay, wherever there's an x, just like, do you remember when we in 2 we had f of x is equal to 2x minus 5. What was f of 3? And wherever there was an x, we had to put that 3, right? Okay, so it's the same thing, except for we're just going to be putting in the equation. So if I'm doing f of g, g is on the inside, so it's going inside. I'm going to say 2 minus 5. I wrote down everything but the x, right? And instead of the x, I'm going to write g of x. So it's going to be x plus 8. Then it's just simplifying. I have 2x plus 16 minus 5. So f of g of x is going to equal to 2x plus 11. I'm just inserting one function inside of another. G of F, order counts, right? So this one, F is on the inside, F is going into G. So I'm gonna write G, only thing I left out was that X. So I'm gonna put in 2X minus 5. Just simplifying, 2X minus 5 plus 8 gives me 2X plus 3. Okay? F of G, G of F means we're just putting in 1. And sometimes you'll see written like that. F of G of X. So let's say I have, let's get a textbook problem. I'm gonna say F of X is equal to 3x squared, 3x plus 2. And G of X is equal to 2x squared minus 1. So I need F of G of X. Let's put G of X into F of X. All right. So G is going inside of F. So my F of X is going to be 3 plus 2. Left off that X. And I've got to insert my G of X. So that's going to be 2x squared minus 1. I'm just putting that in place of that X. And I've got 3x squared minus 3 plus 2. So I have 3x squared minus 1. F of G of X.
What did he say?
Where am I at?
3 times 2.
Yeah, good job. Okay. Let's flip it around and it's going to be a little bit longer. Now you're going to have to do some foiling. Let's find G of F. Any other? Follow your orders of operation, exponents, multiplication, subtraction. So I'm gonna do 3x plus 2 times 3x plus 2. Boiling that out, I'm gonna get 9x squared. I've got 6x and 6x, so that's gonna give me 12x plus 4. Now I gotta take care of multiplying and distributing by that 2, and I'm gonna get 18x squared plus 24x plus 8. That's just distributing that 2. Then I have this minus 1 to take care of. So that plus 8 is gonna turn into a plus 7, right? Insert one in the other. All right. Only other thing we're going to discuss on that is that domain business. Remember, if I have 1 over x, my domain is x cannot equal 0, right? We're going to need these 3 again. If I have the square root of x, x is greater than or equal to 0. And if I have 1 over the square root of x, then I have x is greater than 0. So when I am doing the domain for the composite functions, I have to keep these in mind. Okay? What is going to be the domain for f of x is equal to, what is that going to look like? What is 2x minus 5 going to look like on the graph? Just that line going from infinity, right? So the domain is all real numbers. And what about if I have f of x, or no, I'm sorry, let's make that g of x is equal to x squared. What's the domain of every quadratic? All real? Test question from one day. So if I have all real here and all real here, then my domain for f of g or g of f is also going to be all real, right? If both functions separately have all real, then the function, the composite function, is also going to be all real. But that's not always going to be the case. So what if I have, let's go back to your textbook example problem so you can reference it. So I have f of x is 1 over x plus 2. And g of x is 4 over x minus 1. I'm going to want you to give me the domain for the composite function of f of g of x. What's going to be the domain for this guy right here? What do I have to do? Which one of these is that gonna work on?
The first one.
The first one. I can't have it equal to 0, right? So I've got to start with x plus 2 equals 0. So that tells me that x cannot equal a negative 2. If I just asked you for the domain on this, you would say x does not equal negative 2. What if I asked you for the domain on that one?
X cannot equal 1.
All right, who's my inside function?
G of X.
So the domain for the inside function is part of your answer, automatic. Okay? X cannot equal 1. Domain is the set of x such that x cannot equal 1. But now I'm going to have another part. Because remember, if this is a composite function, then g of x has got to be inserted into f of x, right? Well, what number cannot be here? Negative 2, right? If this x is equal to a negative 2, I end up with a 0 in the denominator, and that's undefined. I don't have that, do I? So if this x cannot equal negative 2, and this function's going in where that x is, what does that say about this entire function?
It cannot equal negative 2.
G of x cannot equal negative 2, right? So that means that I need to do 4 over x minus 1 equals negative 2. Now we got to work that out and find out what number that's going to make, but do you understand why I did this right here? What's going to be, if I were asking you for the composite function of f of g, I would have 1 over plus 2. If I left out that x, what would I be putting in? What would the composite function be? What would go there? So this would be 4 over x minus 1 right there, right? But we know that there can't be a negative 2 here, because negative 2 plus 2 would give me that 0. So that's why I've got to find out what x would make this into a negative 2. How do I solve the rational equations, guys? Did you say pray?
We gonna need all that.
Okay. So multiply both sides by your denominator. And now I've got negative 2 times x minus 1 equals 4. Distribute your negative 2. I've got negative 2x plus 2 equals 4. Subtracting 2 and dividing by negative 2. Negative 2x equals 2, dividing by negative 2. X equals negative 1. So back to my answer, because this is the inside, 1 was part of it. My second part is x cannot equal 1, x cannot equal negative 1. Okay? Remember, on the domain, a lot of times you're telling me what the domain can't be rather than, my domain is going to be every single number in the world except for these two. Because if it was one of these two, I'd end up with a 0 in the denominator. So let's try the domain for 1 over x plus 3 and g of x is just a negative. So what is my domain for f of g of x?
So what would, the x not equal to on the g of x would just be x doesn't equal 0?
Cannot equal 0. Right here, x cannot equal 0. There's nothing to solve. It is what it is. Right? But now, what about this guy? I would write x plus 3 equals 0 and subtract that 3 from both sides. So this would be x cannot equal negative 3. So this whole equation is going in for that x. So if that x cannot equal negative 3, then this equation cannot equal negative 3. So I have to say negative 2 over x equal to negative 3. So I got to find out what number would create that negative 3 in this spot right here. So multiplying both sides times the x. Then I got negative 2 is equal to a negative 3x. Dividing by negative 3. So my other one that it cannot equal is 2 over 3. Okay? Let's try with the other. How about, do you have any clue what I'm doing here? Are we good? No? Let's try one more of these. What if I say f of x is equal to x over x minus 1 and g of x is equal to a negative 4 over x. But I'm going to change it this time. Instead of finding the domain for f of g, I want the domain for g of f. So who's automatically going to be in my answer set? The domain is going to be the set of x such that x cannot equal, Who's inside? Who's the inside function? F of x. So if this is f of x, x minus 1 equals 0, then that says, hey, x cannot equal negative 1. So that's my first part. If I put that whole thing in for this x,
That'd be negative one. It wouldn't be X.
good job. Lord, this day. Good job. All right. This whole equation's going in for this x. So this whole equation cannot equal, what cannot be down here? There's nothing to solve there. What cannot be in my denominator? Right? So I've got to set x over x minus 1 equal to 0. This is why 0 is my favorite number. 0 makes the world turn around, and it makes the whole world a lot more simplified. If I multiply both sides by, then I still got 0, right? So my domain, x cannot equal a positive 1, not a negative 1, and x cannot equal 0. This is your 6.2 domain of composite functions. A lot of times I need to be alone without a group of people around me. If I'm struggling to get something down, I need to be alone. So maybe the video that we're recording now later on will help, and maybe YouTube. I mean, YouTube's taught me to do how to do a lot of things, right? So maybe going back, are we using any of the instructional videos that are posted in your modules, guys? It's good stuff in there. I mean, it's the people that write the textbook that are making, there's videos, there's PowerPoints. Use that stuff out of class to kind of help. All right, we're going to move to 6.2, and you will like 6.2. 6.2 is very, very easy. If I say f of x is equal to 2x minus 5, and I say, is that a function? Would that be, let me rewrite that. Let me say y equals 2x minus 5. Is this a function? We want to always look for a function. What would this graph look like again? Just linear, right? So if I ran the vertical line test across that, would it pass? Or all of my x's are different, right? So it's a function. Now tonight we're going to move from is it a function to is it a 1-to-1 function. Okay? When I was asking you before if a function was a function, we looked at x, right? Now I'm saying if it's 1-to-1, we got to look at y. None of the y's can repeat. None of the x's will repeat because it's already a function, but now none of the y's can repeat. Now instead of having, yes sir?
But if it was a different equation, could the x repeat?
If when I'm asking you this question, I'm going to be saying, is this function? So if it's already given that it's a function, the x isn't going to repeat, right? But good question. So not only do now I have the vertical line test, But with a one-to-one function, I've got the horizontal line test, right? So let's say that I had my parabola. Now, a parabola varies slightly, very slightly, but it does get wider continuously, right? So a parabola is going to pass a vertical line test. It is a function. Would it pass a horizontal line test? No. So a parabola, any quadratic equation may be a function, but it's not going to be a one-to-one function. Because now I've got to look at both the x and the y. This is in your 6-2. What about the cubed function? Y equals x to the third power. What does that look like? That's that long, kind of skinny snake, right? So it's coming through. Now with that pass, that's passing. I know it looks like it's going straight up here, but it's very minutely getting wider. So it's going to pass. It's going to be a function. It's going to pass my vertical line test. Is it going to pass my horizontal line test? Yeah. So the cubed function is a function, and it is also a one-to-one function. Okay? Got to look at both x and y. So if I have an inverse function, inverse just means swap x and y. That's all you got to do, swap the x and the y. If I have the relation 2, -5, 3, 7, -4, 1, do I have a function? Yeah, none of the x's are the same. Do I have a one-to-one function? Yeah, none of the y's are the same. So what would the inverse of this one-to-one function be? -5, 2, 7, 3, 1, -4. My inverse function is just swap your x and y. That's it. Swap your x and y. Okay? If I have a graph, kind of a real popular one. We'll say this is -4, -3. We'll say this is -2, 2. And we will say this is 2, 5. So if I gave you this, how would you graph the inverse? What would the inverse graph look like? Swap x and y. Instead of graphing 2, 5, I need to graph 5, 2, right? 5 of 2. Instead of graphing -2, 2, I need to graph Notice nobody's signs are changing, right? The only thing I am swapping is the x and the y. And if I need to graph -4, -3, then I need -3, -4, right? Now to determine the inverse function, We're still in 6-2. Are we good with inverse? Are we good with 1-to-1? Okay. And again, you want to go back to unit 2, know the shapes of your graph. That's going to answer that question. If I give you any kind of quadratic, you know that the shape is going to be, and you can answer that 1-to-1 business a lot easier. So what if I have f of x is equal to, again, 2x minus 5. And I ask you for the inverse function of f of x. That negative 1 exponent says the inverse. So I need the inverse of f of x. Okay? 3 quick, easy steps. 1, I'm going to get rid of f of x and replace it back with the y. 2, I'm going to swap x and y. So I'm going to say x equals 2y minus 5. And then I'm going to solve for y. Solve for y. I'm going to add 5 to both sides. That's going to give me 2y is equal to x plus 5. And then I'm going to divide by 2. And that's going to give me y equals x plus 5 divided by 2. So my inverse function of f of x is going to be x plus 5 divided by 2. Hard? 2 easy steps. Swap your x and y, solve for y. Okay, let's try a couple of those. We'll start out pretty. So what if I have f of x is equal to 4x plus 2? So I have y equals 4x plus 2. And I'm going to swap x equals 4y plus 2. Subtract that 2. X minus 2 equals 4y. Divide by that 4. And the inverse function of x is x minus 2 over 4.
And that couldn't be simplified further.
Because the 2 and the 4, there'd have to be something on the x term.
Yeah.
All right, we're gonna amp that just a little bit. What if I say, find me the inverse function. Are we caught up?
Would you replace both of the X's with the Y?
Mhm. Yep. Rational equation, multiply both sides by that denominator. That cancels. I had to get this y out of that parentheses, and the only way I'm gonna do it is to distribute that x. So now, yx, 2x, 3y. Now I'm trying to solve for y. So what do you think would be my next step? Not yet. I've got to get these y's on the same side of the equal sign, don't I? I got to have them over there so I can get them together.
Subtract Y.
Subtract that yx. So I'm going to have 2x. I'm going to move up over here. 2x is equal to 3y minus yx. Now, how do I get the y out? It's in more than one term, so it's a common factor. 2x is equal to 3 minus x times y. Factor it out, right? Divide by 3 minus x. There is my inverse function.
The people who missed it are real confused when they come back.
Oh man, they're gonna look at this and they're gonna be like, oh my god.
Well, it's being recorded, hopefully. I'm not counting on anything actually working today. Hopefully it's being recorded and it will be in. Now, and this here, this business, you've been in Algebra 1. You guys did this in 1105, right? You solved rational equations in 1105 where you had to multiply by the denominator.
I'm not gonna lie to you. Whenever I saw an equation like that, I was just guessing my way through it. I was like, that's way too complicated. I got a time test, so I'm just gonna try to speak on it.
That's the thing with math, that kind of stuff comes back and bites your hiney. Everything in math, I mean, you gotta use it the next term, you know? So, I mean, that you kind of gotta, you need those skills from the last class to get you through the next class, because it just builds on itself. All right, I'm gonna, one more thing tonight. How do I tell if two of them are inverse functions or not? So some of these are going to be some yes and no questions. Are they inverse? What you're going to have to tell is if they are equal to each other. This is where we got to go back to 6.1 and those composite functions. Okay? So if I have two functions, f of x and g of x, I know that they are inverse functions of each other if f of g of x equals x and g of f of x equals x. If I can do the two composite functions and simplify them both down to just an x, then I have inverse functions.
That sounds complicated.
Nah. So what if I have f of x is equal to 4x minus 8 and g of x is equal to x divided by 4 plus 2.
This is scary.
No, it's not. Come on. F of g.
You know this stuff. I don't.
Oh, goodness. F of g. That means that this has to replace that x, right? I've got to put this function in for that x. So I'm going to say 4 minus 8 plus 2. Distribute that 4. What am I going to get for 4 times x divided by 4?
Yes.
See, not so scary. What am I going to get for 4 times 2? Then I have my minus 8. These two cancel each other out, so that equals x. So far, so good. F of g of x is equal to x. Now I got to test g of f of x. So I'm going to say divided by 4 plus 2. And what am I going to put in this parentheses? Now, let's simplify that one. Because all 3 terms have a factor of 4, right? What simplifies here? Can I get a 4 out of all of them? So x minus 2 plus 2. It's gone. Equals x. Yes, they are inverse functions. They are inverse functions. My answer is yes. Not that bad. Y'all just see a fraction in the problem, and no matter one little fraction in there, and you're like, oh no.
Yeah, pretty much.
Pretty much, I know.
So we're having like a seizure.
All right, let's do 2x plus 6 and 1/2 x minus 3. 2x g of x f of x. Do I have to sign in?
What did she just say? Did you? That's why I think everybody came to extra points on the case.
Yeah, I think it's
So,
okay.
so
I'm not gonna lie, I haven't even started grading, so y'all are making me not want to start grading either.
bro, the
Please don't.
anticipation.
Please. Oh my God. It'll be a cat.
Okay, f of g.
Pretty confident.
Need to start having parent conferences.
You You think I might be okay?
I felt so
My
confident.
friend lifted out the way.
Bro, you walked out within like 15 minutes. It's like, you're just like.
Excuse me.
me.
Okay, so I'm gonna say 2, empty parentheses plus 6. What's going in my empty parentheses?
Literally, I ain't like it right now,
What's 2 times a half? Minus 6 plus 6, I get x. If I say 1/2 times parentheses minus 3, then I need to put 2x plus 6 in here. Distribute that 1/2. So again, my answer is yes.
Will there ever be a time like there's a number in front of the X?
Mhm.
And then,
There'll be square roots, and you just got to do the composite function and simplify it down to x.
okay, like even like the final answer would be, if it's like, the final answer was like 3X.
If the final answer is 3x, then your answer is no.
Okay, yeah. I was
they're
gonna
not.
say, they have
Yeah.
to be what I pronounced.
You got to get all the way down to just x on both.
Gotcha.
Okay?
Yeah.
All right, guys. We will see you Monday. Monday.
That was like the best.
This is our last, well, this test and final
Oh,
exam.
dude, I went out. I think that grade's not working yet.
Have a good day. Thank you.
I still didn't get over the fact that you just like looked down at the test and then like a couple minutes later, you were walking out. I was like,
Oh, okay.
because I did what I was
I think it's tomorrow. You just check.
Yeah, I'm
All right,
like
thank you.
99% sure I did. You think you did what? I'm pretty sure I did like within 94 plus. Dang. But if I'm any lower than that, I'm gonna be so upset. Because I felt
You're gonna be upset
every
about-
answer.
Not getting a 90.
If you don't think man, I'm supposed to, we'll just trade tests. That's what you really want to do.
Bro, he's got a GPA to helpful apparently.
No, I do not.
He's like, man, I got this 4.0, I can lose it.
I wish.
He's like, I
I
got this
wish.
5.0 GPA.
If I had a 4.0 GPA, then I could have got here for free.
Bro,